All right, let's look at one more characteristic that's really going to be important for you as you work your way into doing these binomial expansions using Pascal's triangle. I have listed on this next page that we've got our first two problems, example 1 and example 2. For example 1, we had a plus b to the second power, and we ended up with this answer, the a squared plus 2ab plus b squared. So our exponent was a 2, and we ended up with these coefficients, which means that the number of terms in our answer, right, was 3. There were 3 terms in our answer. For that next problem, example 2, we had a 3 as the exponent, and we ended up with this answer here. So we circle that was our exponent. We had 4 coefficients there, which means that there are 4 terms in the answer. So the next problem that we'll look at, example 3, because we have 4 as our exponent, right? We're looking at the 4th row of Pascal's triangle. Okay? We have 5 terms that are going to be in our expansion. Okay, so there would be 5. You see there's 5 coefficients. So the main thing that you need to actually add in here, and you can add it onto that other list from the previous problems there, but the number of terms in the expansion is 1 greater than the exponent. Right, which is like our n, right? So I could put a little n in there. So if the exponent was 5, you'd see that there were 6 terms in the expansion, and so on. So here's how we do this with the shortcut. Right, rather than taking and multiplying out a plus b times a plus b 4 times, okay, we're going to go ahead here, and I'm going to take it here, and I'm going to highlight my exponent's 4. That means I'm going to have 5 terms here, and these are going to be our coefficients. So I'm going to take this here, and I'm going to write out like a little template for myself. I know there's going to be 5 terms, so the coefficient on the first term is going to be 1. So I'm going to do 1 and add times something plus our second coefficient be 4 times something plus 6 times something plus 4 times something plus 1 times something there. Now we're going to go in and we're going to treat this here, just in individual parts. So looking at A, we talked about A. One of the things we knew about it here was that it would decrease its exponent from term to term. So our first exponent is going to match whatever our degree is. So we're going to say this would be like 1a to the 4th, which means our second term would have an a to the 3rd. Third term would have an a squared. And the 4th term would have an a to the 1st. And then the 5th term would have an a to the 0. And I'm not even going to write that in there. Let's just save that time for ourselves, not writing in there when it has the 0th power. We know that equals 1. And then our b term, right, our b term increased in degree as we went from left to right. So you could probably start in the back if you wanted to. I think there's less mistakes made that way, right? I know this needs to be a b to the 4th. Then I would have a b to the 3rd, a b to the 2nd, a b to the 1st, and then a b to the 0, which we don't need to write in. And again, hopefully you're noticing here, right? 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, and 4 plus 0 is 4. So we've taken this and we've actually expanded it out. Now we just need to simplify it and make it nice and clean and purty. So we got a to the 4th plus 4a to the 3rd b plus 6a squared b squared plus 4a b to the 3rd plus b to the 4th. And that is our answer. If you want to pause the video and go ahead and try example 4, and then you can check to see if you get it right, that would be just fine. I'm going to go ahead and do it right now. So I know here that my exponent is 6, so I'm looking at that 6th row of Pascal's triangle. Remember, it's not 6 by counting, you're talking about the n values because we do have that 0th row at the top. So I'm going to take this here and I'm going to expand it out using the coefficients I get from Pascal's triangle. I'm just going to move this up a little bit here so we got plenty of space. All right, so I know there's going to be, since there's the exponent's 6, I know I'm going to have 7 terms. It's going to go like this. We're going to say 1 times something plus 6 times something plus 15 times something plus 20 times something plus 15 times something plus 6 times something plus 1 times something there. My a values then, my first exponent on the a, right? We're talking about 6 degrees, so this would be a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and then we won't have an a in the last one. And then we're going to do our b's, and they're going to count. So the first one would be b to the 0. I can do b to the 1st, b to the 2nd. And I know these are right because 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. I have b to the 4th here. 2 plus 4 is 6. B to the 5th. And then the last one would have to be b to the 6th. And then we'll just simplify it down there. A to the 6th plus 6. A to the 5th b plus 15. A to the 4th b squared plus 20. A to the 3rd b to the 3rd plus 15. A squared b to the 4th plus 6ab to the 5th plus b to the 6th power. And that is our expansion. So we'll go on to the next examples here in the next video.